degraded into acetic acid or in the form of butyric acid. Any of the one, it has to be converted from the waste biomass. That ejected electron, when it flows through a closed loop, means then it generates electricity. Not only glucose, sucrose also can do, and another carbohydrate can do, but the easiest way is said to be the glucose. Either it can produce acetic acid or said to be butyric acid. So the rest product is one and the same, and it generates electricity. So the H plus ion, which is generated at the cathode, is generated at the anode is trapped and moved towards the cathode, where cathode gains electron and gets converted in the form of water. So this is the way in which the electron transfer. There is a flow of electron where that is said to be generation of electrical power. So protons moves towards the cathode. Everything I have said, the electrons, the proton taken by the electron gets converted in the form of hydrogen and water. So think of another way. If you use water, then you will produce if you use oxygen as the in the cathodic compartment, oxygen in sense, if you load water itself, means it contains oxygen. So if you load water, that oxygen takes up the hydrogen after reduction, because oxidation happens at the anode, and the process which happens at the cathode is called as reduction. So H plus gains electron, whereas the anode is losing electron, cathode is gaining electron. After gaining electron, the H plus is reduced to hydrogen. That is possible in the cathode. Instead of oxygen, if you think any pollutant, cadmium ion or mercury ion or chromium ion, if you load in the cathodic chamber, that electron from the anode is gained by these metal ions instead of oxygen. So what happens? These ions are present in the cathode. The reduction of cadmium takes place into solid cadmium. A reduction of chromium takes place into solid chromium. A reduction of mercury happens with the production of solid mercury. So not solid liquid mercury. So all these substances, when it is converted into its elemental form, it is also seems to be harmless. So whatever way you can take biomass and water as in the compartment and generate electricity, or take biomass in the anodic chamber, instead of water you take the metal pollutant, environmental pollutants in the cathodic chamber and reduce it. Whatever you do, the process is said to be more effective. As a result of that, what we are going to get is, that is the benefit of electricity. That is the thing which we are going to gain using microbial fuel cell. So any waste can be loaded into microbial fuel cell, provided it must undergo a redox process. If it does so, then it is very easy for us to generate electricity. So how does electric current flow? That is the difference between the potentials of anode and cathode. The electrons are moving, which is technically called as electric current. So by using waste biomass, we are able to generate electrical power. So waste biomass loaded in microbial fuel cell, there is anodic oxidation process followed by cathodic reduction process. During this process, that is anodic oxidation and cathodic reduction, is collectively called as redox process. During this redox process, electrons are ejected under a closed loop. It generates electricity. So instead of an anode and cathode, I have said it plainly, it may be a material made of mainly from a graphite, carbon paper or carbon cloth are employed as a electrode. Why? Because carbon is a cheap metal, one thing. Another one is that is a non-metal which is able to conduct electricity. So generally, graphite rods are used as electrode in soil microbial fuel cells or microbial fuel cells, carbon paper or carbon cloth. Of course, one researcher, interestingly, he has employed pencil carbon, that is pencil lead, as a electrode, and he has generated electricity. All fascinating aspects are going on. If you log on to Science Direct, you can see n number of papers in microbial fuel cells currently. That is after 2021, the field is rapidly exploring, and you can see thousands of paper in microbial fuel cell using different types of electrode, different types of esters, and increasing the power potential and designing the microbial fuel cells. Plenty of areas is thrown open. Of course, in our research area, we are concentrating on one particular biomass and one waste product. How my research is concentrated on the pH and buffering action which happens inside the microbial fuel cell. That is my area of interest in this doing. So I vary the pH of the anodic compartment. I'm going to analyze what happens to the potential. And similarly, I can adjust the buffering action of the anodic compartment. As a result of that, we have to check what is the potential going to be generated. This is my area for research in microbial fuel cell. So rest things remains common for me. However, I am concentrating only on pH as well as the buffering action of this slurry which is present in the anodic compartment. So instead of oxygen, we can use other pollutants also. This is the basic reaction which happens in redox chemistry of microbial fuel cells. That is n number of CH2O means that is said to be the carbohydrate which on reacts with water in anaerobic condition. It generates in the form of carbon dioxide with the ejection of H plus ion with the liberation of electron. This electron has to be transported by the microorganism to the anode by the direct pathway or nanowires, whatever it may be. So this is the anodic reaction. Why it is called as oxidation? Electrons are ejected, released. That's why it is called as oxidation. Whereas if you take up cathode, the oxygen simple, that is a reagent which is present available in the form of water, that takes up this electron in presence of H plus. This will diffuse through the ion selective membrane and produce Er minus Cl is generated in the form of potential and allows the electron to flow. That is said to be the redox chemistry of microbial fuel cell. So instead of glucose, we can use acetate, lactates, and other carbohydrates in the real world situation, or you can use wastewater, landfills, whatever you think of as waste means. It has to be able to ferment. However, usage of polymers in this area is highly limited because, of course, research is going on, but employing polymer to degrade in my microbial fuel cell is seldom limited because the degradation of polymers seems to be very difficult. So we cannot do it since bacteria seems to be very sensitive. The ideal operation condition for a microbial fuel cell to work is within a maximum period of 7 days. If it is a microbial, some other fuel cells are there which can work for 80 to 90 days. But if you use a biomass slurry and start your work, means you have to complete your observations within 7 days sub period of time, because there is plenty of fluctuations in the environment with respect to microbes and other all those things. So study seems to be highly difficult if you prolong your work beyond 7 days. So employing the polymer for degradation in microbial fuel cell cannot be done within 7 days. However, that's why it's not employed for degradation currently in microbial fuel cells. So similarly, you can use particular type of bacteria, facultative bacteria, or anaerobic bacteria. For a particular type of, instead of using consortia, a bunch of bacteria, you can use a single use bacteria which is bacteria is the power output is little bit maximum as compared to a individual bacteria. microorganism which is employed in microbial fuel cell to generate electricity. And looking to the most important challenge of microbial fuel cell is, think of it is able to generate a electrical power in the range of 14 to 59 milliwatts. That is the most important thing. So milliwatts per meter square, such a feeble power it is able to generate. Milliwatts means 10 power minus 3 per meter square of area, exposed area, which is said to be very, very little power in a current scenario. So in our household, what we are doing is we are utilizing 220 volts of electrical power, and what is the ampere? 50 to 60 cycles. If you multiply 220 into 50, then that is the power in watts. Think of that is our human need for electricity. However, think of this watt. This is found to be very feeble. However, what is the advantage? This power we are harvesting from a waste, not from anything else. That is the most important thing. So we are harvesting from a waste, so the power is acknowledgeable. Of course, this is the first to work in microbial fuel cell, in which instead of water they have used a toxic chemical that is said to be potassium hexaferrocyanate chemical K4FeCN6. They are able to reduce it. So this is possible using microbial fuel cell. This blast the area of microbial fuel cell, and most of the researchers then they employed toxic chemicals in the cathodic compartment, and they tried to reduce the pollutant load in the environment. So reduction of ferric to ferrous happens in microbial fuel cell somewhat 20 years to roughly 1990s. So the work has been carried out. So using microorganism, especially that scientists, they concentrate on NAD and NADH electron shuttle. That was a microstructure which is present in microbial fuel cell. So that will act as a shuttle, and they will trap the electron and happens to take to the anode. From the anode, the electron is transferred to cathode, from which the ferric cyanide is converted into ferrous cyanide. That was a novel work which was done 30 years back, which thrown light in the area of microbial fuel cell, which can be employed to degrade toxic chemicals in the environment for the generation of electrical power. Of course, in modern day science, the waste from domestic origin, such as vegetables, fruits, peel, bone, meat, are employed as anodic compartment and degraded it. This is possible. Instead of that, they can employ glucose in the anodic compartment, and heavy metals, organic matter, inorganic particles, pesticides, pharmaceutical outlets, and microplastics. This is the Thron area. So everything we can load it under cathode and degrade it. So we have to design in such a way that either anodic reaction should be simple or cathodic reaction should be simple. If both of them seems to be a little bit stringent, means then power is found to be so difficult. So you can use glucose in your anodic chamber and heavy metals reduction at the cathodic chamber. That is the one way of studying microbial fuel cell. Or you can use water in the cathode and the organic waste in the anode and study it. If you use a bio waste as well as a metal pollutant as the anode and cathodic compartments is, then the system will struggle a lot, and they will not find a fruitful solution for the generation of electrical power. So one of the anodic compartment or the cathodic compartment has to be designed in a simple form, that is using a simple substance. The other thing has to be reduced. If it does so, means the microbial fuel cell will work excellently. So now in modern day science, instead of ion selective membranes, they can use proton exchange membrane, that is a Nafion or Alterix, which is able to circulate the H plus ion efficiently towards the cathode. Of course, modern day science Of course, this is the real MFC arrangements where you can see two leads there. One is anode and another one is cathode. Or another way, this is an anode and another key at the bottom is said to be a cathode. These are real way microwaves. See that the device is very simple and very tiny. Of course, in our lab, instead of that, we have designed using a glass bottles, and the steel rod is meant to insert the membrane to transport the, of course, from anodic to cathodic chamber. Of course, seems to be a yellow colored solution. Of course, what we are trying is we are also trying to convert hexavalent chromium, that was yellow solution, to chromium 3 plus ion by microbial fuel cell. That is also doing in our lab. So this is the working arrangement which seems to be present in our lab for the working of microbial fuel cell. Of course, even though it has plenty of advantages, environmental free and all those things which we have to accept, but what are the challenges is the power production is highly limited. Many microbes are said to be pathogens. While we are working with microbial fuel cell, we must be careful. Otherwise, it will harm us. So, wearing proper gloves and mask, we have to work with the NFC device. And the smell produced in that working area is found to be so offensive. We have to have a mindset up to work in this area. And the most important thing is after doing all those things, the power comes out is in the form of DC current, not in the form, because battery microbial fuel cell is similar to battery, so it will generate only DCs, not ACs, and that too to a maximum potential of, so far reported is 3 volts. So 3 volts only it has been power has been harvested from microbial fuel cells. Still a lot way to reach a potential of 220 volts. So these are the challenges which is faced by microbial fuel cell. But what is the best is we are converting waste to wealth, that is in the form of electricity. So that is the thing which I want to discuss you with today. This was a most pioneering area which produces electricity without harming our environment. Right? Have you followed? Hello?
Yes, sir. Thank you, sir.
Thank you.
Sir.
Any questions from audience?
Participant, any questions? Just unmute.
Hello, sir.
Hello?
Yeah, thank you so much for the wonderful presentation. And I really admire the work that you're doing on the bio generation of electricity using waste. I have one question. Since we are in India, we have a bill passed in 2022 on the net zero emission. That we want to reduce the emission by 2070. So in the microbial fuel process, we have shown that the end product is carbon dioxide along with methane, which goes out as a fuel, and carbon dioxide, which goes out as waste, I presume. So I want to know what is the carbon print of this method, MFC or microbial fuel cells, and how it can be prevented, and how it will help in uh, achieving the net zero emission.
Of course, we are not introducing new carbon to our environment. That is the most important thing. That is carbon dioxide. That is the carbon dioxide is vegetated because biomass has already trapped the carbon from the atmosphere. Is it not? That carbon only we are converting in the form of carbon dioxide. An additional load of carbon dioxide has not been added to the environment. That is the one thing. So net carbon emission is found to be zero, because what carbon which is present initially in the biomass will be answered in the output. So there is carbon balance definitely in microbial fuel cell. That is the most important thing. But what we have to further think of is, even though this carbon comes from a already trapped biosource, this carbon has to be coated, or it has to be trapped into some other way. That we have to work it from out. However, keep strongly in mind, we have not added additional carbon into the environment. Have you got the point?
Yes, sir. Any questions?
Thank you, sir, for sharing such invaluable insight with us. It was truly enlightening. Now we have now we have vote of thanks. As we come to the end of this wonderful event, it's time to express our gratitude. I would like to invite Dr. Sarikova, Assistant Professor of Chemistry, to deliver the vote of thanks.
Thank you, everyone. And thank you so much for giving me this opportunity. We are here at the 5K Development Team is innovation in sustainable research and modern data-driven technologies. We would like to thank the Reverend Father G. E. Arrow-Lodge, the Chancellor of this university, for the immense support and as blessing. It is my great pleasure to express my long-standing concern and gratitude to the Vice Chancellors of this university for his valuable suggestions and the freedom afforded to organize such programs successfully. I would like to thank our resource person, Dr. A.M. Senil Kumar, Associate Professor, the Department of Chemistry, Alagapa Government Arts College, Garai Putin, Tamil Nadu, who made this program great through his wonderful sections. I hope that the faculties have enlightened by his immense knowledge. It is my pleasure to thank our registrar for his energy, support, and encouragement in achieving this goals. My special thanks to the Deputy Registrar for his informed discussion and more support for this event. My sincere thanks to the Dean of Science and the Arts for their generous support during this event. I would like to thank all the entities, that is chemistry, physics, and mathematics, for their encouragements and more support in running this event successfully. I would also express my special thanks to the campus in charge and the PRO, that is Father Augustins and Father Anish, for their technical support and making this program a successful one. And lastly, I would thank the organizing team as well as the teacher and the non-teaching staff for their contributions. Thank you all.
Thank you. Raja sir, shall I leave?
Sir, for the heartfelt words of appreciation, with that we conclude today's event. On behalf of the organizing committee, I would like to thank all of you for your participation and enthusiasm. We hope you found today's program informative and enjoyable. Have a great day ahead, and we look forward to seeing you at next day events. Thanks very much. I wish you all a nice day.
Come to photo section now. Sir,
Raja sir, shall I leave?
you can leave, sir. Thank you, sir.
Oh, thank you, thank you, thank you.